What is reverse engineering? Have you ever wondered how hackers understand software without having the source code? Or how malware analysts break down viruses to see how they work? That process is called reverse engineering. And in this part, I'll explain what it is, why it matters, and how it's actually done. Reverse engineering is the process of analyzing a finished product in order to understand how it works internally. In the world of software and cybersecurity, reverse engineering usually means taking a compiled program, one that has no source code available, and breaking it down to understand its logic, behavior, and structure. In simple terms, instead of reading the instructions that created a program, reverse engineering looks at the final result and works backward. It is like opening a locked machine, examining each component, and figuring out how all the parts interact with each other. This approach is widely used in technology, security research, and software analysis. Reverse engineering plays a very important role in cybersecurity. Security researchers and malware analysts use reverse engineering to study malicious software. By breaking down malware, they can understand how it spreads, what data it steals, how it communicates with attackers, and how to stop it. Without reverse engineering, defending systems against modern cyber threats would be extremely difficult. Another major use of reverse engineering is vulnerability research. By analyzing how a program handles memory, inputs, and system calls, researchers can discover weaknesses that attackers might exploit. These discoveries help developers patch security flaws before they are abused. Reverse engineering is also used to understand proprietary software, ensure compatibility between systems, and learn how undocumented file formats or protocols work. There are two main approaches to reverse engineering software. The first is called static analysis. Static analysis involves examining a program without running it. This includes looking at the executable file, analyzing strings, inspecting assembly code, and understanding program structure. Static analysis helps reverse engineers see the logic of a program in a controlled and safe way. The second approach is dynamic analysis. Dynamic analysis involves running the program and observing its behavior in real time. This might include monitoring system calls, network activity, memory usage, or file changes. Dynamic analysis is often done inside virtual machines to prevent harm to the main system. By combining static and dynamic analysis, reverse engineers gain a much clearer understanding of how software behaves. Reverse engineering relies on specialized tools. Disassemblers convert machine code into assembly language so humans can read it. Debuggers allow analysts to execute programs step by step and inspect registers and memory. Hex editors are used to view and modify raw binary data. Virtual machines provide a safe environment for testing unknown or malicious programs. Together, these tools form the foundation of a reverse engineer's workflow. Reverse engineering is a powerful skill for anyone interested in cybersecurity, malware analysis, low-level programming, or understanding computers beyond the surface level. In future lessons, reverse engineering can be explored in much more depth, including real tools, real binaries, and real analysis techniques. For now, this introduction provides the foundation. Reverse engineering is about curiosity, analysis, and understanding systems by breaking them apart and learning how they work. Don't forget to subscribe, like, share, and comment in order to keep the channel running.